Hey, my PCBs are here. Thanks to JLC PCB, by the way. They said if you mention them in a YouTube video, you might get $50. So, thanks, Daisy. So yeah, they came out perfect. No surprise. I mean, I bought stuff from JLC before. This is for the sand drawing project. It just does what it says on the tin. So the design had a minor snafu in the orientation of this component. There was a disagreement between KiCad and JLC with the orientation, but they did the design review and fixed that for me before they manufactured it, which is great. And they came out absolutely flawless, which I'm very happy about. There's some problems I want to fix for the next revision. I want to add some through-hole connections for the LED, so I can put one on, install a through-hole LED in there that I can have up and snake around the solar panel. And also want to reduce the size of these links here between the ground plane and these through holes here, because they're very difficult to solder, because these big wide traces here can each take like several amps and they need like 100 milliamps. But all this copper around here soaks all the heat out of the joint, makes it really hard to solder. But aside from that, I mean, it's pretty good. I might move this footprint here to keep it clear of the capacitor footprints, but otherwise it's awesome. So these, I ordered 5 of them. This is only 4, and I have here one that I've been charging up. So these crocodile clips here have 2.4 volts on them, simulating the solar panel. And I'm gonna pull the power out. And what's this? It's blinking. Hey! So, so I pulled it out at 2 minutes in the video, let's say. Just for future reference, I'm going to measure the voltage as it goes down over time. So, yeah, the solder joins are pretty grotty, especially where they go onto the big ground planes, the big heat sinks. Really hard to solder to those. So small traces on those ones that are connected to the big copper pads. And you see here you don't technically need this bit of plastic around it, but it makes it hard to put the connector in the wrong way around. But yeah, so I had to solder on that cap, that super cap rather, and these 2 headers here and that header, and she's away. Now it's a bit of a drama to get it programmed. I got this USB ASP, but like I bought it 2 months ago or less, and the latest firmware for these things was released 11 years ago, and it was still running an old version of the firmware. So I had to dig out an Arduino Uno to do the programming the thing with the thing dance. So I updated the firmware in this, screwed around for ages trying to get the right drivers installed to make this thing actually program, and wasn't getting anywhere. So I decided to skip my USB extension lead that I have over here on my electronics workbench and just plug it straight into my USB hub, and it worked a bit better. It would occasionally successfully program, but I'm using the Arduino IDE just because it's got the easy option, and that was the guide I was following for the TPI interface to program these things. That's the tiny programming interface, or 3-pin interface, one of the 2. But the Arduino IDE was misinterpreting the output from AVRDude and telling me that the flash had failed when in fact it was successful, and I just had a pin mapping wrong. I was driving PB0, not PB2. So after I spent a fair amount of time just bashing my head against the wall being dumb, programmed it up and got the code on there. So right now it's just blinking out a Morse code message at a very slow rate. It's just saying SS. That's it. So the code that's running on here is quite primitive at this point. It doesn't use any timers or interrupts or anything. It's just spinning its wheels while it's doing the sleep. So it's not very power efficient. Ideally, it would go into a sleep mode, wake up, read the next bit off the Morse sequence, write it to the LED, then go back to sleep. But for now, I just wanted to do a simple option, a simple approach. That's good enough. If you can't tell, I'm quite tired. So it's been running for 4 minutes, no, 3 minutes on battery, on capacitor, And what's our voltage at? Oh. So we're down to 2.1, and we started at about 2.3, which is pretty good. So that's only running with one undersized cap, so I couldn't get any 40 farad caps, or I think I got 35 or 40 on the actual design. So I've got one 25 farad cap, and it's holding it up for, it's probably gonna keep blinking for a while, even with the inefficient code on there. Because I noticed the LED started blinking as I was charging up the caps. It got to about 1.5, 1.6 volts, and I could see the LED just starting to turn on. So it's actually like the code started running on the 80-tiny before there was enough voltage to fully light the LED, which is pretty wild. But yeah, awesome progress. Bye bye.